So the first question for today's session is this one. So the first question of today's session is this one. Consider a periodic signal xt of time period t. Then the signal is passed through an infinite number of parallelly connected unity gain filters that has center frequency at 1 by t, 2 by t, 3 by t, and dot in this way. And they have delay is this t by 4. So 1 by t has t by 4, 2 by t we have t by 8, and in this way. So the question is, if yt is the sum of all the outputs of the filters, then what will the output actually imply? SSBSC of xt, the ESBSC of xt, C Hilbert transform of xt. So let us solve it. The question is actually, we have a signal xt that is of time period t. So we can write the signal xt with the Fourier series representation. That is actually n tends to from minus infinite to infinite. X of n e to the power j 2 pi n t by t. This t is the time period. Now, this signal is passed through particular filters. Center frequencies are at 1 by t, 2 by t, 3 by t, dot dot dot. And this is the frequency, center frequency. And the delays are like this. T by 4, T by 8, T by 12, dot dot dot. So from this, we can actually say if the delay is tau n is actually T by 4n in this way. So if n is equal to 1, then it is T by 4. If n is equal to 2, then it is T by 8. So this tau here is the delay, is this. From this, we can say the output signal will have frequency specific delay so the first one is centered at T by 4 and the delay tau, sorry, uh, this is frequency is given as 1 by t because that's the period, time period is t, and the delay is for this is T by 4. So the total phase shift that will be provided in terms of e to the power minus j 2 pi fc tau is actually e to the power minus j 2 pi. What is fc for this one? First one delay, this is f1. So this is 1 by t to t by 4. This is actually e to the power minus j pi by 2. Similarly, if we take f2, then the delay is frequency is 2 by t and delay is t by 8. So the same function right now e to the power minus j 2 pi f2 tau 2 will be e to the power minus j 2 pi 2 by t into t by 8. That is again e to the power minus j pi by 2. So the output is always a 90-degree phase shift. So as it is the 90-degree phase shift, it is Hilbert transformation, like T. Okay. So, any question about it?
No, sir.
So let us go to the next question. The next question is about uh, characteristics of SSB-AC signal. You have to calculate it. So just starting the second question here. So suppose we have a signal MT that is given by cos of omega 0 t into cos of omega 1 t. So what will be the Hilbert transformation? Okay, so Hilbert transformation is actually phase shift by pi by 2 radian, that is actually minus 90-degree phase shift. So we can write it as m of t minus pi by 2. That is the Hilbert transformation. So see, this t should be replaced by t minus pi by 2. So here it will be cos of omega 0 t minus pi by 2. That is actually comes sine omega 0 t. Similarly, this term will become sine omega 1 t. So the Hilbert transformation will be m of t is cos of omega 0 t cos of omega 1 t. Then Hilbert transformation is mt minus pi by 2 sine omega 0 t sine omega 1 t. Wait, some mistake I have done here actually. We cannot directly take the minus pi by 2 phase shift here. Sorry for that. One particular mistake has happened actually because I have not looked the forgot that to represent it.
Okay, sir.
Just we have because this is just a direct multiplication, so directly we cannot apply the phase shift. I forgot that one actually. So basically we have to decompose empty first. Empty is actually half of cos of omega 0 plus omega 1 t plus cos of omega 0 minus omega 1 t. Just writing cos A cos B formula from here. It's called cos of A into cos of B. So cos of A cos of A plus B and cos of A minus B. And the half term is there. So now we have to apply the pi by 2 phase shift. Now it is in the additional factor. We can additive format. This is not a multiplicative format. So right now we can apply the phase shift. So the phase shift will be like this: m of h t into half of. Now it converts into sine of, because only phase shift turns cos into, if this cos term becomes sine of omega 0 plus
Omega 0 plus omega
omega
1
1
into t.
t. And this becomes sine of omega 0 minus omega 1 t. So from this formula we can again simplify it and it becomes sine of omega 0 t. So again we had a formula cos of A cos of B, then we represented it in a additive format, cos of A plus B cos of A minus B. Then we applied minus pi by 2 phase shift. Then we got the sine formula, and then we can represent sine of A plus sine of B into sine of A into sine of B. Sorry, cos of B. if you just, this is sine A, this the formula is from sine A plus sine B. It converts into sine of A plus B to cos of A minus B. This formula. So this is the answer actually. So there is the main catch here. Actually, if this is in a multiplicative format, you cannot directly implement that minus pi by 2 phase shift. So you have to come in a linear format, and then you can apply the phase shift in a linear manner. Clear, na? Yeah. Okay. The next question is this one. So there is a SSB signal. And this signal is generated by modulating signal of 1000 kilohertz. And the message signal, that is MT, is actually cos 2000 pi t plus 2 sine 2000 pi t. Another information is given that the amplitude of the carrier that is AC is equal to 500. So we have to find what is the lower sideband of the SSB signal. This SSB signal is generated by, probably this is hertz. I don't think it is 100 hertz, 1000 hertz. So you have a message signal MT. This one is the message signal. And amplitude of the carrier is this. So you have to find what is the lower sideband of the SSB. This is the question. Okay. So the lower sideband, we can write it like this. x of LSP t is actually what? Magnitude of the carrier signal into message signal into cos 2 pi fct plus do the Hilbert transformation, and then we multiply sin 2 pi fct. So the message signal mt is given as sine of 2 pi into 1000t minus 2 cos 2 pi to 1000t. And AC is also given 500. So first we have to get what is the Hilbert transformation. So m of h of t is actually what? Again, in the previous question we have derived a similar pattern. So m of h of t is actually pi by 2 phase shift of this signal. So that will be, the sine will be into cos. And as it is minus pi by 2 phase shift, then there will be a negative. Right?
Yes, sir.
Yeah. Just wait a minute. Just making it sure. Oh, I forgot to write it right. From here we get sine 2 pi the 1000t with the term 2 in front. And this is also a negative term. This is mh of t. Now we have to replace all these terms in the above equation in XLS method. We have mht here. We have what is the value of AC and what is the value of mt. So just let us calculate it. So if we replace all the values, it will be 500, that is AC. Then I am putting the value of mt. This is the part mt. Over negative sign. I think it's very. The problem is I have to again go back and again have to write it. That's why I'm. But this signal was plus. That's the problem. Mistake on it. So plus of this. So you guys also do it on yourself because all the terms I have given to you. Thousand T cos 2 pi fct minus sorry. This is the term that will come from here. And then if we solve this with all the cos A, cos B formulas or sin A, sin B formulas, the output will come as x of LSP of T is equal to 500 cos 2 pi fc minus 1000 T minus 200 sin fc minus 1000 T. So this calculation probably we have got some ambiguity, but the main logic is here. The LSB side is actually carrier frequency multiplied by signal by cos part and with Hilbert transposal with sine part. Then you know what is the message signal MT? That is sine 2 by 1000 T, that is written here. Sorry, we have mistakenly written as sine. That's the reason we are just. It's better that you guys tell me that I'm writing something wrong. Yeah. Okay. So this is actually cos. So the mistake happened. And this is plus 2 sine 2000 pi t. So this is actually sine 1. Then what we did?
Bottom one, MH, H on H of
Then
T will change,
MH of T will
minus sign.
MH of T will be changed.
Yes, yes.
That's why we were just suffering the calculation part. not make the answer correctly. That's all. Because you took the input wrongly. So mh of t will be sine of 2 pi
2 pi and 1000
1000 t
t.
minus 2 cos, because this is sine, and minus pi by 2 specific will make it minus 2 pi 1000 t. And then you have to just write this one. mht is given by this, and mt is given by this, cos 2 pi ct sin 2 pi of ct. Then you have to just replace these two are for cos terms. We have divided. This term is mt, and this term is actually, so this is m of t, this is m h of t, and this is the multiplication term cos, and this is the multiplication term sine. We have expanded it actually here, and then you have to just solve that. These are the cos a cos b, sin a cos b, sin a sin b, cos a sin b. There are four formulas. You have to just write it as, expand these things, and then you will get this simplified equation. The rest of the thing are actually trigonometric formula. You have to do it on your own. Sure. But the main concept is actually that, how to calculate the LSP. Is it clear, right?
Yes, sir.
Or do I have to do the trigonometric equations also? We can do it actually. We can think. And also, just telling the fact that from this equation, you have to take those terms for which FC is lower side band. Because they have asked what is the lower side band. So you should, the center frequency is given. These will be higher side band. So you have to take the lower side band term. So any FC that is greater than that, you have to take the lower side band. So left hand side of the FC. Okay. I think we'll go one more question today and then we'll just stop it today. Surely. Suppose there is a message signal MT with bandwidth B. And this is modulated with a carrier frequency Fc, where Fc is actually greater than the bandwidth. Now, to form a VSB signal, the modulated signal is passed through a high pass filter. Which has gain, this filter has a gain is equal to 1, maximum gain. Let me write. This filter characteristics is maximum gain is 1, and slope is alpha, not infinite. Slope is actually alpha. So the question is, find out the excess bandwidth it requires as compared to its SSB modulated counterpart. So I'm just giving the picture also because it will be helpful for you. So the maximum gain is 1 of the filter. That is said in the question. And the filter has a slope of alpha. So what will be the filter looks like? And then it is this one. This is the center frequency. Sorry. This is the center frequency. And let me draw the picture so that so this is the filter for the VSB1. So this distance is delta F and this distance is also delta F. So this is Fc plus delta F and this is Fc minus delta F. This is Fc. So this is the filter characteristics, high pass filter. So the question is again, MT is a signal with bandwidth B and then it is modulated with a carrier frequency Fc. And Fc is greater than B. So the carrier frequency is very large than the signal band. Then we want to form a VSB signal. So to form the VSP signal, what we will do? We just pass this modulated signal through a high pass filter that has a maximum gain of 1 and slope of alpha. So it has the maximum gain of 1 as it is a high pass filter. After Fc plus delta F, it always has the gain 1. But for lower frequency, it is 0. Beyond Fc minus delta F, it is 0. And there is a slope in between Fc to form the VSP signal. So we have to talk about what is the excess bandwidth with respect to the SSB counterpart. So just draw this picture again. Make it clear. So the excess bandwidth is this part because single sideband they do not take the other half. So the slope is actually alpha is equal to 1 by 2 delta f because the slope you want to calculate, this is delta f, this is delta f. So the slope is 1 by 2 delta f. And then this excess bandwidth delta f is actually 1 by 2 alpha from this equation. So the excess bandwidth compared to SSB is actually 1 by 2 alpha. That is the slope. Is it clear? Okay. So this was all for today. We will meet in the next Saturday.
Okay. Thank